Good morning. Welcome to Trinity online classes. I am Vivian Suresh Kumar, lecturer in mathematics. Today we discuss the concepts of conic. Conic. Definition of the conic. The locus of a point. The locus of a point. The locus of a point moving on a plane. Moving on a plane such that its distance from a fixed point and a straight line and a fixed straight line and a fixed straight line on a plane are in a constant ratio E is called a conic. The locus of a point moving on a plane such that its distance from a fixed point and a fixed straight line on a plane are in a constant ratio E is called a conic. That means the fixed point, it may be S, the fixed point on the fixed line, the constant ratio. The constant ratio E is obtained. It forms a conic. The locus of a point moving on a plane such that its distance from a fixed point, suppose it is the point, its distance from a fixed point and a fixed straight line on a plane are at constant ratio. is called a conic. In this case, the fixed point is called a conic. The fixed point is called a focus. And it is denoted by S. The fixed point is called a focus. And second point, the fixed straight line is called a directrix. The fixed straight line is called a directrix. The fixed ratio, that means the constant ratio E is called, is named as eccentricity. The fixed point is called focus and the fixed straight line is directrix and the fixed ratio is eccentricity. We draw a line passes through focus and perpendicular to the directrix. A line we drawn passes through the focus and perpendicular to the directrix is called the axis of the conic. A line which passes through the focus and perpendicular to the directrix is called axis of the conic. This is the definition of the conic. In this case, the ratio, suppose E equal to 1. The conic is a parabola. Suppose the ratio E equal to 1. That means SP by PM equal to 1. E equal to 1. The conic is a parabola. If 0 less than E less than 1, the conic is a ellipse. The conic is called a ellipse. If E greater than 1, the conic is a The conic is a hyperbola. The conic is an ellipse, a hyperbola. Suppose E equal to 1, the conic is parabola. 0 less than E less than 1, the conic is an ellipse. E greater than 1, the conic is an hyperbola. Suppose if E equal to 0, the conic is circle. E equal to 0, the conic is circle. Suppose if E equal to infinity, the conic is a pair of straight line. The conic is a pair of straight line. The conic is a pair of straight line. The locus of a point moving on a plane such that its distance from a fixed point and a fixed straight line on a plane are in a constant ratio, E is called a conic. The distance from fixed point and fixed straight line in a fixed ratio, the locus is called conic. Here the fixed point is named as focus and it is denoted by S, and the fixed straight line is directrix, it is a straight line, and the constant ratio, the fixed ratio E is called named as eccentricity. Here suppose the fixed ratio E equal to 1, the conic become a parabola. Suppose if 0 less than E less than 1, the conic is an ellipse. If E greater than 1, the conic is hyperbola. If E equal to 0, the conic is a circle. If E equal to infinity, the conic is a pair of straight line. The conic is a pair of straight line. The locus of a point, that is the locus of a point. The locus of a point moving point P, moving on a plane, such that SP by PM equal to E, where PM is the perpendicular distance, from point P to the directrix. Is called a conic. That is, the locus of a point P moving on a plane such that SP by PM equal to E, where PM is the perpendicular distance from point P to the directrix, is called a conic. Next, equation of a conic. Here conic definition is SP by PM equal to E, where E is the fixed ratio, that is eccentricity, the fixed constant ratio, that is eccentricity, and SP is the distance from focus to point P, PM is the distance from point P to the directrix. Next, equation of a conic. Section. Let S alpha comma beta be the focus, and AX plus BY plus C equal to 0 be the equation of directrix. Let S alpha comma beta be the focus and AX plus BY plus C equal to 0 be the equation of the directrix, and the constant ratio and the fixed ratio be, and the fixed ratio, the eccentricity and the eccentricity bracket low fixed ratio be E. Then we know that the definition is SP by PM equal to E, where P x comma y, x1 comma y1 be any point on the conic. any point on the conic. Any point on the conic. This is the fixed point that will be named as S. This is the fixed line. The line is ax plus by plus c equal to 0. It is directrix. Let P be any point on the conic, that is x1 comma y1. By the definition of the conic, SP by PM equal to E. Therefore, SP by PM equal to E. Cross multiplying SP equal to E PM. SP, we know that the distance, SP is the distance from S to P. Here the S is focus, alpha comma beta. SP means that is the distance between the 2 points S and P. Therefore, x1 minus alpha whole square plus y1 minus beta whole square, that equal to E into E be the fixed ratio, that is eccentricity. PM equal to perpendicular distance from point to the line, point to the directrix. PM equal to perpendicular distance from point to the directrix. If the equation of the directrix is ax plus by plus c equal to 0, we know that the perpendicular distance from point P x1 comma y1 to the line ax plus by plus c equal to 0 is modulus of ax1 plus by1 plus c by square root of a square plus b square, squaring on both sides, squaring on both sides. Therefore, square root of x1 minus alpha whole square plus y1 minus beta whole square equal to e square into modulus of ax1 plus by1 plus c by root of a square plus b square whole square. Square root cancelled. Therefore, x minus alpha whole square plus y1 minus beta whole square equal to e square into ax1 plus by1 plus c whole square by a square plus b square. This is the equation of the conic. The locus of P x1 comma y1 b x minus alpha whole square plus y minus beta whole square equal to e square into ax plus by plus c whole square by a square plus b square. This is the equation of the locus. Equation of the locus. Here, equation of a conic section B. Equation of locus of conic. Equation of a conic section B. Let S alpha comma beta be the focus. Ax plus by plus c equal to 0 be the equation of the directrix, and E be the eccentricity, that means fixed ratio. By the definition of the conic, SP by PM equal to E, SP equal to EPM. SP equal to the distance from focus to the point, that is square root of x1 minus alpha whole square plus y1 minus beta whole square equal to E into the distance from point to the directrix is modulus of ax1 plus b1 plus c by root of a square plus b square, squaring on both sides. Finally, the locus of P x1 comma y1 b x minus alpha whole square plus y minus beta whole square equal to e square into ax plus by plus c whole square by a square plus b square. This is the equation of the conic section. The equation of the parabola. We know that a conic section for eccentricity equal to 1, that means the fixed ratio is equal to 1. The conic become a parabola. We substitute e equal to 1. Therefore, x minus alpha whole square plus y minus beta whole square equal to 1 square. That means ax plus by plus c whole square by a square plus b square. Therefore, x minus alpha whole square plus y minus beta whole square equal to ax plus by plus c whole square by a square plus b square. This is the equation of the parabola. This is the equation of the parabola. Here conic for e equal to 1, the conic become a parabola. This is the equation of the parabola. Here the axis of the parabola is directrix is, here equation of directrix is ax plus by plus c equal to 0. Therefore, the equation of axis of the parabola is the equation of axis of the parabola is already we discussed. We know that the axis of the parabola is nothing but the line passes through the focus and perpendicular to the directrix. The line passes through the focus. Here focus is alpha comma beta. The line passes through the focus S The line passes through the focus and perpendicular to the directrix is called the axe of the conic. In this case, parabola is called axe of the parabola. The line passes through the focus and perpendicular to ax plus b plus c equal to 0 is of the form b into x minus alpha minus a into y minus beta equal to 0. The equation of the axe of the parabola is here b into x minus alpha minus a into y minus beta equal to 0. This is the equation of the axe of the parabola. Now, the equation of the standard form of the parabola. Equation of the parabola. Equation of the parabola. In standard form. In standard form. The equation of the parabola in standard form. Let S be the focus. Let S be the focus. And let S be the focus. And L be the equation of directrix. And L be the equation of the directrix. Equation of and L be the equation of the directrix. Let S be the focus and L be the equation of the directrix. Equation of the directrix. We draw a line. Drawn a line perpendicular to. Drawn a line perpendicular to directrix. Perpendicular to directrix and passes through the focus, perpendicular to the directrix and passes through the focus S. Focus S. Drawn a line perpendicular to the directrix and passes through the focus S. Suppose the diagram like this. This is focus S. This is the line, equation of the line directrix. First, this is line L equal to 0. We draw a line perpendicular to the directrix and passes through the focus. Perpendicular to the directrix and passes through the focus. Here, Z is the projection of S on directrix. Let Z be the projection of S on directrix. Projection of S on directrix. Next, we take let A be the midpoint of SZ. That is, we take a midpoint of SZ, that is SA equal to AZ. We take a midpoint of SZ, that it be A. Let take SZ equal to small a, then automatically SA equal to AZ equal to small a, and we draw a line parallel to directrix and passes through A, passes through the point and passes through the point A. We draw a line parallel to directrix and passes through the point A. This is AY, named as AY. Let take AY as y-axis and AS as x-axis. There, so the point A is 0, 0. We take AY as y-axis, AS, it is also named as AX, AS as x-axis, AX as x-axis. So this is y-axis, this axis, automatically A is origin And we know that the distance between A and S is small a, this is small a. Therefore, the coordinates of S is A comma 0. The focus S A comma 0. This is origin 0 comma 0. Automatically this is A comma 0. Any point lies on x-axis, its y coordinate is 0. The distance from origin to point is A, therefore A comma 0. It is negative side. The coordinates of Z is minus A comma 0. The coordinate, it is origin, it is the negative side of the x-axis. The coordinates of Z is, the distance is A minus A comma 0. Any point lies on x-axis, y coordinate is 0. Therefore, the equation of the line, the equation of the y-axis is x equal to 0. The equation of the line y-axis is x equal to 0. The equation of the line parallel to y-axis and passing through the point minus A comma 0. The equation of the line parallel to y-axis and passing to the point minus A comma 0 is x equal to x coordinate, that is x equal to minus A. Therefore, x plus A equal to 0. Therefore, the equation of the directrix is x plus A equal to 0 and focus S is A comma 0. Let P be, let P x1 comma y1 be any point on the parabola. Any point on the parabola. Actually, definition is SP by PM equal to E conics. It is a parabola since E equal to 1. Therefore, SP by PM equal to 1. That implies SP equal to PM. That is SP equal to PM. Actually, definition of the conic SP by PM equal to E. Here, the conic become a parabola. The eccentricity equal to 1. Therefore, SP by PM equal to 1. SP equal to PM. Let Px1 comma y1 be any point on the conic. Maybe that is P. Join SP. PM is the M be the foot of the perpendicular, like the projection of P on directrix, where M be the projection of projection of P on directrix. Therefore, SP equal to PM. The distance from S to P, the PB locus point, here x1 comma y1 is square root of x1 minus A whole square plus y1 minus 0 whole square equal to PM. The perpendicular distance from point to the line, here the equation of the line is x plus A equal to 0. We know that the perpendicular distance from point P, x1 comma y1 to the line ax plus by plus c equal to 0 is modulus of ax1 plus by1 plus c by root of a square plus b square. According to that formula, modulus of x1 plus a by square root of, here line for x quotient is 1 square plus 0. Squaring on both sides, square root of x1 minus a whole square plus y1 square whole square equal to modulus of x1 by a whole square by 1 square, 1 root 1 is 1. Therefore, x1 minus a whole square plus y1 square equal to x1 plus a whole square. y1 square equal to x1 plus a whole square minus x1 minus a whole square. That equal to y1 square equal to, we know that a plus b whole square minus a minus b whole square equal to 4ab, that equal to 4ax1. The locus of p x1 comma the locus of p x1 comma y1 b y square equal to 4ax. This is the equation of the conic in the equation of the parabola in standard form. The equation of the parabola in standard form is y square equal to 4ax. Here, equation of the parabola in standard form is y square equal to 4ax. First, let me take S be the focus. Let me take first S be the focus and L be the equation of the directrix. First, we draw a line perpendicular to the directrix and passes through the focus. Perpendicular to the directrix and passes to the focus. This is called the axis of the parabola. And the projection of S on directrix is named as Z. we take a midpoint of SZ, that it may be A. Let we take A be the midpoint of SZ. That is, midpoint means the distance from SA equal to AZ. Let it be taken as small a. Therefore, A is the midpoint of SZ. SA equals small a. Automatically, AZ is also a small. Next, we draw a line parallel to the directrix and passes through A. We draw a line parallel to directrix and passes through A, that is named as AY. Next, we take the AY as y-axis and AS as x-axis. So automatically AY as y-axis, AS as x-axis, A is the origin. A is the origin. The distance from A to S is small a, therefore the focus S is A, 0 and automatically the coordinates of Z is minus A, 0. This is the equation of the directrix passes to the point minus A, 0. We know that the equation of any line parallel to y-axis and passes to the point minus A, 0 is of the form x equal to x coordinate, that equal x equal to minus A, x plus A equal to 0. The equation of the directrix is x plus A equal to 0. Next, we take let P x1 comma y1 be any point on the parabola, that is locus point. By the definition of the conic SP by PM equal to E, here it is become a parabola, therefore eccentricity equal to 1, SP by PM equal to 1, that implies SP equal to PM. Where M be the projection of P, M be the projection of P on directrix. Therefore, SP equal to PM. SP is the distance from focus to the point, that is x1 minus A whole square plus y1 minus 0 whole square under square root of, that equal to PM. PM is the perpendicular distance from point to the directrix. We know that the perpendicular distance from point x1 comma y1 to the line ax plus by plus c equal to 0 is of the form modulus of ax plus b x1 plus by1 plus c by root of a square plus b square. Applying that formula, we got the relation. Squaring on both sides, simplifying on y square equal to, this is of the form a plus b whole square minus a minus b whole square, that equal to 4ab. Therefore, the locus of p x1 comma y1 be y square equal to 4x. This is the equation of the parabola in standard form. This is very important question in IP. Conversely, suppose SP equal to square root of the distance from S to P is x1 minus a whole square plus y1 minus 0 whole square, that equal to square root of x1 minus a whole square plus y1 square. We know that here y1 square is 4ax1, y1 square is 4ax1, that equal to square root of a minus b whole square plus 4ab, that is a plus b whole square, like square root of x1 plus a whole square, that equal to modulus of x1 plus a, that is modulus of x1 plus a. Suppose we draw a projection from P to x-axis. We draw a projection that is named as point N. Draw a projection, N be the projection of P on x-axis. P on x-axis. Therefore, the point N is here, the distance from y-axis to the point is x1. Therefore, it is x1 comma 0. Any point lies on x-axis, its y coordinate is 0. This line is parallel to y-axis. This line is parallel to y-axis. Therefore, the point N is x1 comma 0. Here, the distance from these two origin A to N is x, and the distance from Z to A is small a. Therefore, the total distance from Z to N is x plus a. Here, the distance from A to N is x1. The distance from A to Z is small a. Therefore, the distance from Z to N is x1 plus a. Therefore, modulus of x1 plus a, we write that named as the distance from NZ. It is the nothing but distance of NZ. NZ is nothing but the distance of PM. That is nothing but PM. Therefore, SP equal to PM. There SP by PM equal to 1. The ratio is 1. The conic become a parabola. This is the conversely proof. Actually, need not to prove converse. It is enough to prove the equation of the stand form is y square equal to 4ax. Next, chord. The line joining 2 points The line joining 2 points on the parabola is called the chord of the parabola. Is called the chord of the parabola. Suppose this is the parabola. The line joining any 2 points on the parabola is called the chord of the parabola. Next definition, focal chord. Focal chord. A chord which passes through the focus. A chord which passes through the focus is called focal chord. Is called focal chord. That means any chord which passes through the focus. A chord which passes through the focus is called focal chord. A chord which passes through the focus is called focal chord. Next, double ordinate. Double ordinate. A line which is perpendicular to the axis of the parabola and passes through a point P is called double ordinate. A line which simply called a chord which perpendicular to the axis of the parabola. A chord which perpendicular to the axis of the parabola and passes through a point P is called double ordinate. Is called double ordinate. Double ordinates are like this. The chord which is perpendicular to the axis of the parabola. The chord which is perpendicular to the axis of the parabola is called double ordinate. Next, latus rectum. Latus rectum. A line or a chord with a line which join the 2 points on the parabola and perpendicular to the axis of the parabola and also passes through the focus is called latus rectum. Latus rectum are defined like this. A chord which passes through the focus and perpendicular to the parabola is called latus rectum. A chord passes through the focus and perpendicular to the axis of the parabola is called latus rectum. General latus rectum are denoted by the coordinates L, L dash. Latus rectum are denoted by the points L, L dash. Latus rectum are defined as, latus rectum is defined like the doubled ordinate passes through the focus. Latus rectum is defined double ordinate passes through the focus, or focal chord perpendicular to the axis of the parabola. Simply, a chord passes through the focus and perpendicular to the axis of the parabola is called a latus rectum of the parabola. Length of the latus rectum. Length of the latus rectum. Let the equation of the parabola be. Let the equation of the parabola be y square equal to 4ax, that will be named as equation 1. This is the parabola in standard form. This is the equation of the tangent at the vertex. Equation of the tangent at the vertex, that will be named as y-axis. Here the equation of the y-axis is x equal to 0. This is the axis of the parabola. Here focus, yes, a comma 0. Vertex a 0 comma 0. L dash be the length of the latus rectum. Last point we discussed L dash. L dash be the latus rectum. L dash be the latus rectum. L dash be the latus rectum. And we take, suppose the length of the latus rectum is L dash. Length of the latus rectum is L dash. The length of the latus rectum is L dash. Let SL equal to L. let SL equal to L. The length of SL is L. Therefore, the point L becomes, here this line is L dash is parallel to the y-axis. L dash is parallel to the y-axis. Therefore, here x coordinate is A. Automatically here x coordinate is also A and y coordinate be L. Because the distance from x-axis to the point is L. The distance from x-axis to the point is L. That is nothing but y coordinate. Therefore, L. So, let SL equal to L. So, the coordinates of L is A comma L. But the point L lies on the parabola, y square equal to 4ax. Therefore, the point must satisfy the equation of the parabola. In place of x, replace a, and in place of y, replace L. That means L square equal to 4a into a. L square equal to 4a square. L equal to plus or minus square root of 4a square. Therefore, L equal to plus or minus 2a. Here L equal to 2a comma minus 2a. Therefore, the points are that means the coordinates are L and L dash are L a comma 2a and L dash a comma minus 2a. These are the points on the parabola. These are ends of the lattice rectum. Therefore, the length of the lattice rectum L dash equal to square root of a minus a whole square plus 2a whole square, that equal to 0 plus 4a whole square that equal to square root of 4a whole square, that equal to mod 4a. 4 into mod a. The length of the lattice rectum L dash equal to 4 into mod a. Therefore, the length of the lattice rectum of the parabola y square equal to 4ax is mod 4a. Here A is the S focus S a comma 0 and A be the point, A be the vertex of the parabola 0 comma 0. Y square equal to 4ax for A 0 comma 0 be the vertex of the parabola S focus A comma 0. L dash are the ends of the lattice rectum. We know that the definition of the lattice rectum is a chord which passes through the focus and perpendicular to the axis of the parabola. This is called the lattice rectum. Focal distance. The distance, focal distance, the distance of a point on the parabola, the distance of a point on the parabola from its focus is called focal distance. Focal distance of the point. Suppose the equation of the parabola is y square equal to 4ax. The parabola became like this. This is the axis of the parabola. This is the equation of the tangent at the vertex. This is the vertex point A, that is 0 comma 0. This is focus S a comma 0. Let it be point P. The point P is suppose x1 comma y1. M be the projection of P. On directrix. M be the projection of P on directrix. This is joined SP. We draw a projection from P to x-axis, that is N. The coordinates of N be x1 comma 0. Last problem we discussed the coordinates of N be x1 comma 0. Therefore, here the focal distance of the point, P is SP. The focal distance of the point P is SP. By the definition of the parabola, SP is nothing but PM. Definition of the parabola. SP equal to PM. PM is nothing but NZ. PM is nothing but NZ. NZ is nothing but the distance from NA plus AZ. The distance from NA plus AZ. The distance from N to A is x1. The distance from A to Z, this is A comma 0. We know that this is minus A comma 0. The distance is A. Therefore, the length SP equal to x1 plus A. The focal distance is x1 plus A. In this case, we take it is always modulus. The length of the focal distance SP equal to modulus of x1 plus A. We take positive. x1 plus A. x1 is the coordinate of the point on x coordinate of the point P, and A is the in the form of y square equal to 4ax for A is taken. A is the x coordinate of the focus SA comma 0. Therefore, the focal distance of a point on the parabola is from its